All right, this is section 10.3, part 2. All right, so now that we've gone over all the things that are the same and how we can find a p-value for a hypothesis test for the population mean, let's actually look at an example. All right, so in this first example, and of course there's lots of words here, and we have to always, as we read through these problems, try and figure out what words are meaningful, what numbers are meaningful, and what do I need to pull out from this, from the data that I'm given or the information that I'm given. So as I go through, I'm probably going to write down a few things, maybe in this upper right-hand corner, just so I can keep notes of what all's happening. All right, so we are told that we are going to assume that the resting metabolic rate, RMR, of healthy males in complete silence is 5,710 kilojoules per day. Researchers measured the resting metabolic rate of 45 healthy males who were listening to calm classical music and found that their resting metabolic rate found their mean resting metabolic rate to be 5,708.07 kilojoules per day, with a standard deviation of 992.05 kilojoules per day. And our question is there evidence to conclude that the mean metabolic rate of males listening to calm classical music is different than what it would be if they were in complete silence, 5,710 kilojoules per day? And we're told to use a 5% level of significance. All right, so I do have several numbers here. I am going to note that the expected mean is this 5,710 kilojoules per day. And then I've got some sample statistics. And we had a sample of size 45. The mean of that sample was 5,708.07. And the standard deviation was 992.05. And then, of course, alpha is 0.05. All right, I'm going to transfer that over to a blank page, and we can start looking at our conditions for a t-test and then setting up our hypotheses. All right, so first of all, let's make sure all of our conditions are met. We were told that there was a random selection of 45 males, so we're good to go on that first condition. We don't necessarily know if resting metabolic rate is a normally distributed thing. However, our N is 45, so we've met the condition that our N is greater than or equal to 30. And as far as our third condition, is our sample independent, or is our sample size no more than 5% of the population size? And whereas, if you're selecting people, typically you can assume that it's a random selection, that one person's resting metabolic rate will not affect someone else's resting metabolic rate. But if we just want to check, when we take, I've got to grab my calculator. Let's see, and it turned off. If we take 45 and divide by 0.05, there we go, we get 900. So basically, what we want to make sure of is that our population is at more than 900 people. And I think it's safe to say that that's met. All right, so here is all of our information that we had from the problem. We have what we expected to be in silence. We have our data from our sample of 45 people, 45 men who were listening to classical music. And we want to know, does classical music have an effect, basically, on resting metabolic rate? And of course, in order to come up with our hypotheses, we can come up with our null hypothesis without needing to know what we're actually trying or being asked to find. But we're going to need our the question again so we can make sure we get the correct alternative hypothesis. And so our question becomes, or goes back to, is there evidence to conclude that the mean resting metabolic rate of males listening to calm classic music is different than the resting metabolic rate when they're in silence? And so that's what we want to look for. Therefore, of course, our null hypothesis, no matter what, in this case, is always going to have equals, but in this case, it's going to be that the mean is equal to 5,710. And our alternative will be for it to be different. That means either direction. Is it less or more? And of course, now we can look at it and we can say, oh, well, that's smaller, so we could have just said less than. But we came up with the question before, or the question would have been created before we collected our data. So we're going to use not equal. All right, so we're going to go to our trusty TI-84 calculator, hit the stat button, of course, go over to test, down to t-test. And remember, we need to change our input from data to stats. So we don't have data, we have just the mean and standard deviation. So we're going to put in our null hypothesis. So remember, this is going to be the null. We're going to put in the data that our problem gave us. Mean, standard deviation, 992.05, and then our sample size, which was 45. Then we're going to go down here and we're going to make sure we have our alternative hypothesis set. Now in this case, it's already set to not equal, so we're just going to leave it, but we could always change if we need to. And of course, when we hit calculate, here's all of our great information. And so, you know, it's nice because it reminds us what the alternative hypothesis that we tested is. So there's that should match up with the alternative hypothesis that we wanted to test. Then we get our test statistic. So again, on the homework problems, when it asks what is the test statistic, it's going to give you T equals, and then it's going to give you a box. And I want to say it asks for this to 3 decimal places, which I know is different. For a z-score, we always went with 1 decimal place, but I'm pretty sure that for the t value, they ask you to do to 3. But whatever it says to do, always just round to whatever the homework asks you to round to. Then we get our p-value. That's our really important, what we're going to be using for our analysis. And that p-value, I'm going to go to 3 decimal places. This one rounds, interestingly, because that 6 is going to take that 9 to a 10. Or the way I like to think about it is that 6 is going to round that 89 to a 90. So that's going to be 0.990. And of course, that is a very large p-value, which is probably not too unusual to expect, considering we weren't even 2 kilojoules per day off from what we expected. So this hopefully isn't very shocking or surprising. But we can compare what is our p-value versus alpha. Well, 0.990 is definitely greater than any value for alpha that you will ever use. So we can definitely say that we fail to reject. So remember, we can only reject the null hypothesis if we have an unusual sample, a sample that makes us doubt our information. This more supports the same, that the resting metabolic rate is basically the same whether you're sitting in complete silence or listening to calm classical music. Now, if it had some different type of music. Maybe they want to study what happens if you're listening to upbeat music. Then maybe that's different. Or what happens when you're listening to jazz or some other, form of music, or even just noise. But that would be a different population. So that would be a different hypothesis test. So I'm going to fail to reject the null hypothesis. And then, so that's my decision. For my conclusion, I'm going to go to the next page just so I have a little bit of room to write it out. All right, so one thing that I want to do is to remember what my question was. And so here we go, just copied from the beginning page. Is there evidence to conclude that the mean resting metabolic rate of males listening to calm classical music is different than 5,710 kilojoules per day? So we had insufficient evidence. So there is, or we have, or however you want to word it, there is insufficient evidence. And this is because we failed to reject. The null hypothesis. So just as a reminder, that's how we know that we have insufficient evidence. So there's insufficient evidence at this point, with the p-value we got, it would be at any significance level. But again, I like to make sure that whoever's reading my conclusion understands what level I was testing at. So at the 5% level, can't write today, of significance, to suggest the mean resting metabolic rate of males listening to calm classical music is different from, and now I'm going to take a small liberty here. Rather than saying different from or different than 5,710 kilojoules per day, I'm not going to use that number. I'm going to say different from the resting metabolic rate of males sitting in complete silence. And either way would be right, but that's what we were testing. We were testing if it would be different to be sitting in silence versus listening to classical music.